Look at in this video is we're going to figure out this special segment that's in isosceles triangles. So again, we're going to look at an investigation, and what we're going to do is we're going to figure out something about this isosceles triangles that's special about one of the segments in them. So in this lesson, don't worry about completing the warm-up. It's not necessary for you to understand the lesson. So again, here's what we're going to do. First, I want you to consider a scalene triangle. So we have a scalene triangle drawn over here. And in this scalene triangle, you'll see that we have three different segments drawn. We have CD, which in this case, CD is the altitude of to the base from AR. So it's the altitude from point C to the base of the triangle. We have CE. CE is the angle bisector. All right, so CE is the angle bisector of angle ACR. And then we also have CF right here, and CF is actually the median to the base from angle C, vertex C. Okay, so we have those three different lines, and what you'll be able to notice here is that clearly all three of these lines, the altitude, the angle bisector, and the median, are all three different lines in this triangle. So our question is this true for all triangles? Okay, so is it true that the altitude, the median, and the angle bisector is different for all triangles? And we want to take a look at, is it possible for two of these to be the same segment, or could they all be the same segment? So what we're going to do is we're going to complete an investigation that looks at this, and we're going to focus on isosceles triangles. So we're going to do this investigation. If you're interested in doing so, you can follow along on a separate sheet of paper, but I'm going to do this on the smartboard. So the first thing that it wants us to do is it says to construct a large isosceles triangle on a sheet of paper. So there are a couple ways that you can do this, but the first thing that we're going to do is we are going to start by drawing a line segment. And then I'm going to put a point anywhere up here. Let's make it a little bit smaller than that. We'll put it here, and we'll call that point K. Okay. Now, in order to construct an isosceles triangle, what we need is we need to have two segments that are the same distance from point K to the base of this triangle, or this line segment that we have. So what we can do to draw that is if we adjust our compass like so. So you have the distance from K to this point right here. And then if you draw your arc, you have over here another point that is the same distance from K as the one that's over here on the right. So if we take this, we now have a triangle. We will draw this in, and we will make this triangle have, we'll say, blue sides. So our triangle looks like this. If you take our straight edge, you have K to A, and you have K to R. So, and this will go ahead so that the whole triangle is in blue. We'll draw that down there. Okay, so there's an isosceles triangle. We have triangle A, R, K. Now, the next thing it says is construct an angle bisector KD. So we want to construct an angle bisector from, we want to bisect angle K here. So what we'll do is we will draw in our arc like so, and then we would take our compass and we will measure that arc length like so. We will draw our second arc like there. Flip this over, bring this right there, and then we will draw this other arc. And so now we have an angle bisector. We go ahead and we take our straight edge, and we'll draw the angle bisector and we'll make it green. Okay, so our angle bisector goes from K, oops, right there. Okay, now let me do one thing here. Let me adjust this thickness of this line. Make it green. Okay, so we go from K through there. All right, so there we go. That is our angle bisector. Now the question, and we'll call that point D. I'll write that in. So that's point D. Now, the question it asks is, do triangles ADK look congruent to RDK, this triangle? So does the triangle on the left look congruent to the triangle on the right? If they are congruent, then what we can say is KD is the line of symmetry. So what we're going to do to see if they are congruent is we are going to compare the sides using our compass. So here's what we do know. We do know they share side KD. So side KD is congruent to KD. We also know that AK and KR are congruent because this is an isosceles triangle. So we have AD is right there. If you look at that, you have RD is the same length as AD. So we now know that AD is the same length as RD. So what does that mean? That means that D is the midpoint, and so that means that KD is perpendicular, and it is a perpendicular bisector of that. Okay, so now we have, well, my fault. So we have KD here. So that means that it is D is the midpoint of AR. Okay, so what we have here, and finally it says compare angle ADK and RDK. So ADK and RDK, compare those angles. Those angles are both right angles. They're supplementary because we know that this bisects this, KD bisects this at a right angle, which means that it is an altitude. So what we now have is KD is a median to the base because it goes from vertex to midpoint, so that's a median. It is an angle bisector because we bisected the angle, so KD is an angle bisector, and it also intersects, it is the perpendicular bisector of AR, so it is also an altitude. So KD is an altitude, angle bisector, and a median, which if you think back to what we were just talking about, we asked, can all three of those segments be the same line? So in this case, they are. So if we jump back to our notes, we have this vertex angle bisector conjecture. And what the vertex angle bisector conjecture states is, in an isosceles triangle, the bisector of the vertex angle is also the altitude and the median to the base. Okay, so what we know is that if you have an isosceles triangle and you create the angle bisector of the vertex angle, that line segment is also going to be your altitude and the median of that base. So what we're going to do is we're going to walk through how to prove this conjecture. Okay, so in the investigation, what did we discover? We discovered that the symmetry of an isosceles triangle yields a number of special properties. Okay, so in order to prove this, what we need to do is we need to prove two conjectures. So those conjectures are: if a triangle is isosceles, then the bisector of the vertex angle is an altitude, and if a triangle is isosceles, then the bisector of the vertex angle is also a median. So we need to prove these two statements. Now, in order to prove these two statements, we are going to need to prove one other thing. We're going to need to prove what's called a helper property. And that helper property is a statement that we prove so that we can use that property in the proof of the statement. Okay, so this helper property is called a lemma. It is something, a lemma is something that we prove that allows us to help prove something else. So again, that's why it's called a helper property. So the lemma that we need to prove is that the bisector of the vertex angle in an isosceles triangle divides the isosceles triangle into two congruent triangles. So what we want to do is, if we look at this, we want to prove that this triangle over here is congruent to this triangle over here. So in order to do that, we're going to use a flowchart proof. The flowchart proof has been filled in slightly. We are going to fill in a few things. So if we look at this, we are given that triangle ABCD is isosceles, AC is congruent to BC, and CD is the bisector of angle C. So that is what we are told. So first, we are in our flowchart proof, we're given CD is the bisector of angle C. Now, if you look at this next box, it says the reasoning for this next box is the definition of angle bisector. So if we look over here, that what needs to be in that box is, we're saying the definition of an angle bisector would be that angle 1 is congruent to angle 2. All right. Now, we also know that triangle ABC is isosceles with AC congruent to BC. Why do we know that? It's given. And remember, we also said when we were talking about it on the smartboard that CD is congruent to CD because they share that side. So it's the same segment. So what we now know is triangle A. So what we have now is triangle ADC is congruent to triangle BDC. And we know that because we have side and we have angle and side, angle, side. So side, angle, side congruency conjecture allows us to make that statement. So we've now completed the proof of this lemma. So what we can now assume is true is that the bisector of the vertex angle of an isosceles triangle divides that triangle into two congruent triangles. Now, what we wanted to do is we wanted to prove that CD is an altitude. So remember, our statement, that our conjecture that we're trying to prove is that the for an isosceles triangle, that the bisector of the vertex angle is also an altitude to the base, and it's also a median. All right. So if we look at this, we know, again, we state everything that we have. Triangle ABC is isosceles with side AC congruent to BC, and CD is the bisector of angle C. That's given to us. Now, because we know that triangle ABC is isosceles, and we know that CD is the bisector of angle C, we can use our lemma that we just said, where those two triangles that are created, ADC and BDC, they are congruent. That's our lemma A. And then we can say angle 1 is congruent to angle 2. And if you look at that, why do we know that these two are congruent to each other? Well, since we know that these two triangles are congruent, those are corresponding parts. So CP, CT, C. So we know angle 1 and angle 2 are congruent to each other. We also know that angle 1 and angle 2 form a linear pair. Because they're a linear pair, we know they're supplementary. And because they're congruent to each other, the only two types of angles that are congruent to each other that are supplementary are 90-degree angles. So that's a right angle. Now, the next thing we know is, or next thing we can say is, CD is parallel to AB. We can say CD is perpendicular to AB. Why are we allowed to say that CD is perpendicular to AB? Because they intersect at right angles. And that is the definition of perpendicular lines. Okay. Now, what we can then say is, because CD D goes from vertex to opposite side and intersects that side at a 90-degree angle as perpendicular, we can then say that CD is the altitude of that angle. So CD, or of that triangle. So CD is an altitude. And that is because the definition of an altitude is a perpendicular line that goes from a vertex to the opposite side. Now, we have proven the first part of that statement. We proved that in an isosceles triangle, the bisector of the vertex angle is also the altitude. You're going to prove the second part in one of your homework problems using a flowchart. Now, let's look at one other example. How can we apply all this? So it says the perimeter of XYZ, triangle XYZ, is 11 centimeters. YZ bisects angle XYZ. So since my YZ, my fault, that is a typo. YL. YL bisects angle XYZ. So what does that tell us? That tells us that this right here is an angle bisector. So since that's an angle bisector, we know that this angle is congruent to this angle right here. Now, let's label what we know. We know XY or XL is equal to 2.1 centimeters. So that's 2.1 centimeters. Now, it says we want to know what is the measure of XY. So what is the measure of this side right here? And we also want to know what is the measure of LYX, meaning what is the measure of this angle right there. So let's use what we know. First off, we know that this is an isosceles triangle. Now, what did we just learn? We learned that if isosceles, so if you have an isosceles triangle, whoops, so if I could spell words, that would work. Isosceles, okay? If isosceles triangle, then what we had is angle bisector equals altitude and median. Okay, so let's think about what that tells us. So it tells us YL is an angle bisector. Okay, so that line is an altitude and a median. So not only do we know that XL is 2.1 centimeters, but we know that YL bisects ZX. Why do we know that? Because the definition of a median is that it is a line segment that goes from a vertex to the opposite side to the median of the opposite side, or by fault, to the midpoint of the opposite side. So since XL is 2.1 centimeters, we know that ZL has to be 2.1 centimeters. So if we know that to combined, those two sides are 4.2 centimeters, and we know that this is an isosceles triangle, that means that we know that these two sides, X or YZ and XY, that we know that they are the same length. So if the perimeter is 11 centimeters, we subtract 4.2 centimeters. So 11 minus 4.2 is 6.8 centimeters. Then we know that the other two sides of the triangle, XY and ZY, we know that XY is congruent to ZY, so we divide 6.8 in half, so we get XY is equal to 3.4 centimeters, which is the first part that we wanted to show. Now, the other thing that we want to show is we know that we want to figure out the measurement of that angle that we highlighted in red. Now, because triangle XYZ is an isosceles triangle, we know that the two base angles are congruent, so that's 40 degrees over here. Now, we know YL bisects that third angle. Well, if the two base angles add up to 80 degrees, that means the measure of angle ZYX is equal to 100 degrees because they have because of the triangle sum conjecture. Now, if YL bisects that angle, then 100 divided by 2 gives us that the measure of angle LYX is equal to 50 degrees. So that is the second piece of the triangle that we wanted to determine. So we have used the information from the vertex angle bisector conjecture to help us figure out the measurement of xy and the measurement of angle LYX. So you're going to work on your homework here. You're going to complete those problems. If you have any questions, message me on Remind or an email, and then if you have any questions on the homework, we can go over them during class.